Good day, students. This is the part 2 of numbering systems, and this is just to show you where we stopped. We stopped at binary to decimal conversion, and now we're going to continue where we talk about the binary to hexadecimal or hexadecimal to decimal conversion. And these are extremely important in regarding to IP version 6. So just to show you where you can find the slide, if you go on to Blackboard, right, you would then find under term 1 there is lessons and homework, and then you'll find term 1, and you can go into the folder, and then you'll find number systems ICF 152. So this is the slide that was added apart from the normal numbering system slide, which is more about IP addressing. This one is more to make you understand how hexadecimal conversion works with regarding to numbering systems. Right, so now I'm going to continue with the slide. So we've covered the part of binary where if you say 1 plus 1 is 2, 1 plus 1 is 10, why would that be true? It's basically binary, so it's not decimal, that's binary format, right? So if you look at numbering systems, these things are going to be skipped for now because these are more ICF. That's going to be skipped. The main things that you know that a bit, right, is basically your 8 bytes, right, which you would have at the bottom here. You can just do the highlighter, right? So that, right, you add it all up, and that gives you amount of bits you have, right? So if you count this is what? 1, 2, 3, 4, 5, 6. Is that 6? No, it's not 6, because you have to add everything. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That is 16 bits, right? And that's how your memory and everything else works, but we'll get to that, right? That's why you get 32-bit and 64-bit with your Windows operating system. Also, that is how you understand how this whole software works. We have 32-bit Windows, 64-bit Windows, 32-bit Office, 64-bit Office, and that's all about the bits, the amount of processing that it can handle. So we've covered base or radix, right? And you all know what's a numbering system. So these are the important things that we'll look in this slide. A nibble is 4 bits, right? That means that is half your 8 bits, right? That's a nibble. A byte is basically your 1 byte, right? And it can also be a character as well, where you get characters where we will get to ASCII, but we're not going to cover that for now, right? So continuing, that you will see that a bit makes up 1 byte character, right? 1 bit is 1 byte, right? And a character can also be a number, alphanumeric, or symbols. This is ICF. We're not going to get to that now. So let me skip this. So important thing is you understand what's a base decimal number, what's a binary number, and what's a hexadecimal number. This is for CNF. Right, so decimal, we've covered that it's a base 10, right? We've covered also the notation that you have to do it as in base 10. That's the notation of how you would do decimal, right? The digits would be from 0 to 2, 3, 4, 5, that. And then also the largest value is a 9, right? So the place valuation note, the value notation would then be 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4. And as I said in the earlier previous video, that this is how you would work it out. So if you had to convert this number and bring it back to find out how the value notation works, you would then have to go from right to left, right? So you go from right to left, and you would then 2 to the power of 1, which is actually 10 to the power of 0, which would be 1, so that would be 2. So you added 2 plus the 1. The 1 is, you get the 1 from the 10, and that's what the 10 represents there. But your 7 is your number that you're trying now to convert, right? But this is basically how you would write it down in decimal. So if I have to move on, not to stay with decimal for now, binary has the similar approach, as you can see. So binary works in base 2. The notation is a 2 at the bottom to say it's binary, and the digits is just 0 and 1. That's binary, nothing else, nothing more, just 0 and 1. So if you look at the previous example, this was the decimal number, right? Which was 120 in decimal format, 120, right? Now if you look at the next one, right, this is 110, but it's in binary, so it's 110. So that's no decimal number, that's a binary number, right? Now if you had to put that into decimal, you would then use your binary table, and you should know that by now, that your binary table would be 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. And if you look at those three, you can then use that and work out this number to convert that to decimal. Now if you look at this would then be 1, which would be there as 1, right? And then that should be a 1 there as well, right? And that should be a 0. If you look at this example here in front, I'm talking about this example, this one here, right? So you would then say that if that's a 1, then that becomes positive, so it would be 1 times 4, right? And that would be 1 times 2, right? And then you get your decimal answer, right? And that's how you would then do your conversion. You could also use a table, which will make it much easier for you to understand if you use your binary table. Octal we're going to skip, as we said, we're not going to cover this. But then we look at hexadecimal, and hexadecimal has a similar approach where you would know that it's a base 16. The notation is 16 at the bottom, and a decimal, the hexadecimal number would be where you have letters also in, because this is hexadecimal, and these are the digits of hexadecimal, the range. So it will go from 0 to 9, and then A, B, C, D, E, F, right? That goes up to 15. That's your hexadecimal. The largest value of a digit is F, right? Why do we say that? If you had to put this in a, let's just do a blank screen, right screen. If you had to put this in, if we say it's F, right? That's the largest. So if you had to do this, 1, 2, 3, 4, 5, 6, 7, 8, right? So you would then have, what is this, 8? So 8, 9, 10, 11, 12, 13, 14, 15. That's 15, right? So if you count all this up, you will understand that if this is your 0 and this is your F here, right? And this is your largest number that you would get, right? Going back to hexadecimal. So largest value of a digit is F, right? We'll explain later on how do we get to F, because if you have to convert F, you get 15. 15 is your decimal number of F, right? And 15 would then be all the ones, right? So if you look at this number here, right, and you had to convert this to decimal or binary, this is how you would do the conversion. So we look at your place value, which is 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, 16 to the power of 3, 16 to the power of 4, right? Because you're dealing with 1, 2, 3, 4, 5, right? But if you had to use this 12A, 812 as an example, right, this one, and you don't look at this, then the A would then be placed here. That would be the A, the 1 and the 2 would be there, right? So then you would put a 2 in place of the 4, you would put a 1 in place of the C that you see here in front, which becomes 12, but 1 would be 1 there, and then the A would then be placed here instead of D, right? And then you would then use that A would then be 10 if you look at the place value, because this is 0 to 9, then 10, 11, 12, 13, 14, 15, right? So then that would become a 10. So it would be 10 times 256, and then you'll get your answer. And then you plus that with your 1 times 16, and you get your answer. And then you have your 2 times 1, right? Because 16 to the power of 0 is 1. And then you get your answer. You add that numbers together, and then you get your decimal value, right? And then from your decimal value, you then use your binary to convert that to binary. Okay, so let's skip this is still base 16. And this is your base conversion table, right? So as you can see, decimal can go up to 21, right at the bottom. Binary just goes as in, it can go to any amount of number depending on where you stop it, but it's only valued at ones and zeros. Octal, we're not doing octal, so that's a no. Hexadecimal, as you can see, you can go to F, which is your largest decimal number, there. And then after F, it starts 10, 11, 12, 13, 14, 15. That's basically how it works, but we just work to the letter F. So if you look at these examples, so this is decimal to binary. There's your decimal figure, which is 216, right? And if you had to use your binary table, you would then know how to get to this. Because if you look at this, that's all zeros, right? But you basically do you add it together after you do your division, right? So 216 divided by 2 gives you 108, right? Meaning 108, 216 is more than 128. Remember, this is 128 according to your binary table. So you then take your 128, you can do it the other way around, and you take it to the 2, and you take 216 minus 128, and you get your value, right? If you get the positive value, that becomes a 1, as you can see here, right? Because this is the longer method. So to make this easy for you, let's put this in this way. Color black. Drawing the table again. 1, 2, 3, 4, 5, 6. Let's call that 7. You have that there. So that would be 128, 64, 32, 16. That would be 8, 4, 2, 1. Right? That's your binary table. Now, if you had to take 216, can it go into 128? Yes, it can. And then the remainder would be, you work it out. Can it go into 64, the remainder? Yes, it can. Right? Then you'll get to 54, as you can see here. Right? Obviously 54 is your, it's bigger than 32, so that becomes a 0, right? And then you can then take a look at the following example. So let's do this way. So alright, this is the older method to do this, but if you want to do the other way around, this is the longer method of the decimal to binary. The other way would be you take 216, right? And you minus that by 128, right? 128 gives you what? You get 88, right? So that gives you 88, right? Now you've already used the 1, 2 and 8, and that's why that was a 1, right? Then you take the 64 going to 88, so you take 64, right? Let me just do this, paste that. Okay, so we would then just go back to pointer, so you will then take 64, right? And that would minus what? 64 minus, it's actually 88. 88 minus 64 equals, right? You get 24. Now 24 is smaller than 32, so 32 cannot be used. As you can see, that's why it's a 0, right? But 24 can go with 16, so 24 minus 16, what would that be? That would be 8, right? But 24 can go into 16, that's why we're selecting it, right? That would be 8, right? And then 8 minus 8 equals 0, so 8 is being used. And there you've solved. You've now successfully went through that whole 216 to get to 0. The rest then becomes zeros, and that's how you get your converting from decimal to binary, as you can see in this example, right? So you could either go this method, which is this one, or you can go the subtraction method, where you just subtract from your largest numbers, and you subtract till you get 2. Every time you use the number that's available in your binary table, that number becomes a 1, and that's how you work out your binary. Or you work it where you have to do division, right? And you divide it by 2, and then you get your answer, and then your remainders you carry that over, as in this example here, right? So let's move on to this is the one that I just showed you now. So what I explained here on this little example here is on the next slide, as you can see here, right? So you start from left to right, as I said, and then you compare the place the value in 1 if the cell is being used, right? So you sum of the decimal in place, values of the cells contains a 1, that value is 216, and that's what I just did in the previous example, as you can see, without even coming to the slide. So this is another way to do it. Right, this is the short method, and this is the longer method, as you can see. Right, so then you have decimal to hex, which is this one here, and we're not going to cover base 8, right? So as you can see here, that 216 to hex would then mean you have to take the place values, right? Because remember, 6 is 16 to the power of 0, that is 16 to the power of 1, and that is 16 to the power of 2, right? But you now need to remember that this is a decimal number, and to convert decimal to hex you have 2 place values, right? So you look at 216 divided by 16, which means the 2 here in front. Okay, so this looks a bit confusing for you, because you can see that we took a 216 decimal and then we converted it to D8, now hexadecimal. Now the D represents on your hexadecimal table, I go back, the D is a 15, no, it's a 13, right? It represents 13 if you go back to your table. So going back to this, that should be 15, right? So, but not to confuse you with this, let's go on to the next step, and then you will see how we got from hex to decimal and the way this conversion works, right? Because there is something similar that would help you with this conversion, where you work with remainders. So if you look at bin to hex, we've discussed that your hexadecimal is a abbreviated way of writing binary, and each hexadecimal digit represents 4 binary bits. Now that is extremely important that you know that each hexadecimal, oh, it's wrong color, just undo that. Each hexadecimal represents 4 binary bits. 4 binary bits, very important, right? And in 4 binary bits is your nibbles, as we said earlier. So a group of binary bits in groups of 4, right? Starting from left to right, sorry, from right to left, from right to left. Convert each group of 4 bits to a hex equivalent, right? So if this is your decimal, right, which is this amount here, then you would then break that out into 2, which would be your 4 and then your 8, right? So that becomes your 10, because D is 10 and that's 8, and that's where you get to D8, right? Because that is how you break down your binary. So if you had to look at this and we had to convert this to binary, we will then be easily to convert this to D8, right? Without using that. So if you do your binary table, which you will see here in front, if I could have just taken this table, it's much easier. But just to use this as an example, you would then see that 216 is a decimal number, and we now saw in this example that this is your binary number. So if you take these one and this one, right, you would then have your 2 hexadecimal values, right? So you would then say that this is, you don't look at this table now, this is with hexadecimal, you only work with the 4, right? So you would then only need to understand that it's 1, 2, 4, 8, right? So that would then be put in a table, it would be 1, 1, 0, 1, and then you add it all up together. So that would be 8 plus 4 plus 1, right? And what value would that be? 8 plus 4, right? And then 1, you will get your answer. And then you use your other table, which is, I'll just do it here. Okay. 4. So it's 1, 2, 4, 8, right? And that would be 1, 0, 0, 0, right? So that answer is obviously it's 8, right? Because 8 is the only one that uses binary. You probably now figured out this answer because 8 plus 4 is 12 plus 1 is 13, right? So if you look at the next example, there is the 13, right? But then the 13 was divided by 16, which gives you the remainder 13. And the 216, right, was divided by 16, it gives you the remainder 8. Right, there's the 8 and the 13, right? That's how they got to that. So 13 then gets converted to D, to that, right? Just going back to this example, so you would then obviously add those two together to understand how this conversion works, right? So there's your 8 and there's your D. Now D is actually not 13. Let's see what I'm missing. I'm missing a step. Okay, got it. So we weren't missing a step, we just needed to know that this is the figures, right? But now we need to convert this, and to convert this you have to use let's just go back to hexadecimal. So I then have to use this table here, right? This one here. And as I said, the notation, so 16 to the power of 0 and 16 to the power of 1, right? So you put your 13 and your 8, which we got previously. If I go back to this, yeah, right, this is where you converted that. You got your decimal, which is 216, you converted to binary, right? And then you took that binary and you divided the table into 2 nibbles or 2 values, right? And then you got 13 from the one block and you got 8 from other block. But then you have to put that now into your into your table, how you do your conversion. So the 8, which is the D, or the D, sorry, which is 13, right? In the hexadecimal is a D. It's times 16 gives you 208, right? And then you plus that 8 times 1, which is 6 to the power of 0, gives you 8. And if you write it out, you will get back to 216. And that's why D8 is equal to 216 in decimal value, right? So that's how you convert from hexadecimal to decimal or binary to decimal. I can show you another example based on that. This is basically a first step, which you do if you have to convert the binary number into hexadecimal, right? Remember, 4 binary bits is 1 hexadecimal digit, right? We're not going to do octal. You can see octal is similar, but it's smaller. The method for binary to decimal is that you know now how it works. Hexadecimal, we just discussed this now, and we're not going to do octal to decimal, so that is the end of the slide. So as you know that if you get your numbers, you have to put it using this, let's just go back. You have to make sure that you use the 16 to the power of 1, 16 to the power of 0. When you do the conversion, you need to use this conversion table. It's extremely important, and that will guide you how to convert from decimal to hexadecimal and vice versa. Thank you.